All right, getting into section 6.2, where we're going to use proportions to solve. All right, so that's our learning target, solve proportion, and use them to solve real-world problems. A proportion is just a statement of equality between two ratios. For example, right, 1/2 and 2/4 are the same ratio, right? And I could keep going, right? I could say 3/6 and so on. Those are proportions. They are proportional. They have the same ratio value. Um, you use that in cooking, right? If a recipe calls for 2 eggs or 2 cups of water, or whatever the case may be, and you want to double it, or you want to make 1.5 batches or something like that, you have to keep that ratio of ingredients to match what it is that you're making. Cross products, we cross multiply to solve proportions. And cross products, if they're proportional, if they're equal ratios, will always be equal. So if we look at our example, 1/2 and 2/4, we know that this is a true statement. And there's two cross products, right? 1 times 4, which is 4. And then this cross product of 2 and 2 is equal to 4. So those are proportional, right? For example, if they're not, like I know that 1/3 and 2/7, right? If I want to check, are those proportional, right? 3 times 2 is 6. 1 times 7 is 7. Those are not equal. It is not a proportional relationship. And what this statement allows me to do is it allows me to solve for a variable. Like if I have a over 4, and I know that that's equal to 1/2. Okay, so I could say, well, what is a? And I should know what it is, but it allows me to cross multiply, right? And it's 2 times a has to equal 4 times 1. And when I divide both sides by 2, we get a equals 2. So that's the value that will make that proportion a true statement. So we'll use that cross multiplication to first tell, are they proportional, and the second, solve proportional relationships. So, for example, it says determine the pair of ratios is a proportion. And we looked at this last chapter, if you remember. I can just divide 1 by 3 on my calculator, get a decimal value, divide 3 by 9 on my calculator, get a decimal value. If they are the exact same, then they are equal. Then it is a true proportion. So that's still an option, but we can also test, are the cross products equal, right? So if I multiply here 1 times 9 and the other cross product 3 times 3, are they 9? So yes, that is a proportion. However, and I'm testing this, does that equal 2/5? And I can multiply 4 times 2, and I get 8. And 1.2 times 5 is only 6. So that is a no. Those are not proportional, right? And if you were to type that in your calculator, 1.2 divided by 4, it's not going to give you the same as if you did 2 divided by 5. So you can still do it that way, but this is another way to test if they are equal to one another. Now, here's what we need that concept of cross multiplying is to solve for a missing variable, right? So if I look here, let's look at some things. I can see this ratio right here, 52/100, 52 out of 100. I know that that's a little over half. All right. And if I think about half of 25 is 12.5, I should know that my value should be a little bit more than 12.5. But here's how we solve that. So I take cross products, right? 100 times A, and then 25 times 52. That should give me 1,300. And now I divide. And we get A equals 13. And again, you can test it out if I plug in 13. 13 times 100, does that equal 25 times 52? And the answer is yes. Or you can type in your calculator, 13 divided by 25. Does that give you the same value as 52 divided by 100, right? 0.52 is what your calculator should tell you in both cases. And so, yes, that checks out. So let's look here. And you'll see that it doesn't matter the order in which you do the multiplying. I always pick the variable first, just because I like it on the left side of my equation. And you'll see a pattern that emerges here, right? So we got 15 times m, and then 12.5 times 7.5 is going to give me 93.75. And then I'm going to divide by 15, right? Because that's 15 times m. Got to divide the other side by 15. And we get m is equal to 6.25. Right? And I can plug that back in, right? If I did 12.5 divided by 6.25, I get 2. If I did 15 divided by 7.5, I get 2. So I know that that is the correct value there. And you'll see that the pattern is we always multiply. So there's going to be two numbers that are in the cross product, and then there's going to be one that has the variable. We multiply the two numbers, and we end up dividing by the one that's partnered with the variable. So here we divided by 100. Here, the 15 was paired with the variable, so we divided by 15. All right, so if you look, what number gets paired with the variable here? Right, it's the 5, right? So this is, we're going to end up dividing by 5 after we multiply the two numbers, right? So we'd have 5x equals 60, and divide by 5, we get x equals 12, right? And if you think about it, right, they're proportional. The values are the same. If I did 5 times 4, I get 20. If I did 3 times 4, I get 12, right? So that would be a proportional statement. They would be equal fractions. Using them to solve problems. So it says in the first one, a 3 by 5, right? So my original is 3 by 5. It gets enlarged, so the length of the new photo gets bumped up to 7. And I want to find what the width of the new photo would be in order to keep it proportional, right? Not get distorted. So I know that this is 7 and this is X. I don't know what that is. That's what I'm looking for. So that's one way to set it up. So what I did was I went width, length, and then here width of the new one, length of the new one. So I just have to be consistent with my setup, right? Another way, let's say that I went 5 over 3, right? That's fine. Some of you might have put that on top, right? So this is length, this is width. As long as I'm consistent on the other side, length and width, right? Notice when we cross multiply, it'd be 5x and then 3 times 7. Here, 5x, 3 times 7. So the cross products would be the same. You could say that, okay, 5 is a length of the original and 7 is the length of the new. Well, I could compare that to the widths, right? The width of the original is 3. the width of the new is what I'm looking for. So again, I just have to be consistent. Notice my cross products would still give me 5 times x and 3 times 7, right? So when I do my cross multiplying, I get 5x equals 21. And notice that would be the same in any of these setups. Divide both sides by 5, I get x equals 4.2. All right, number 2 says you have a recipe that calls for 12 ounces of juice for 16 ounces of soda. If you only have 10 ounces of juice, how many ounces of soda? All right, again, let's look at some different ways to set this up. Let's just go in order, right? So I have 12 of juice for 16 ounces of soda, right? That's what the recipe, right? So this was my recipe. I only have 10 ounces of juice, so that has to go on top, and my variable would go on bottom, right? That's one way. I could have that flipped, right? I could have said, okay, I'm doing soda first, right? 16 versus 12. And then this would be x over 10, right? Because this is soda, this is juice. I could have said, all right, well, I know that it calls for 12 ounces of juice, but I only have 10 of that. Well, I have to have that same ratio for soda, right? So here's my recipe. My recipe calls for 16. I got to figure out how much I'm going to need. So any of those, right? And then I could even flip that. I could say a 12 over 10 equals x over 16. So there's a lot of ways. You just have to be consistent with your setup, meaning if I have juice on top here, juice on top here, soda and soda. So when I cross multiply, it would give me 12x, right? And notice in any of these scenarios, 12 is paired up with the x. Equals 16 times 10 is 160. So if we divide both sides by 12, we get x equals, what does it go in there? It goes in there once, 40, so that would be 3. And then that would be 40. Double check 0.3. Yeah, so that'd be 13.3 repeating, or 13 1/3 ounces of soda. All right, using proportions to convert measurements, right? And we did this in section 6.1. We didn't really cross multiply to do it, right? We did it in a sequential order, but the ratios would stay the same. For example, it says there's 3.28 feet in 1 meter, right? Well, that would be proportional to the 100-meter dash. So it says rate of proportion be used to find the distance in feet. So this is what we're trying to find is feet, right? So I don't know what that is, but I know it's a 110-meter dash. And I'm going to relate this to what we did on section 6.1, so you can see. And I know it's confusing because, well, we did it where the meters were on top, and so the units canceled. But watch this. So if I were to multiply here, I would get x equals, and then if I cross multiplied here, the 3.28 feet times 110. So let's do that real quick. So 3.28 times 110, we get 360.8. Okay, and so we cross multiply there to solve. And notice that we set it up as a proportion. There was an equal sign in between. Now let's talk about what we did yesterday, right? So yesterday we would have had 110 meters. And we would say, okay, I'm trying to get rid of meters. And I know that there's 1 meter in 3.28. Let me clean that up. For every meter, we have 3.28 feet, right? And so we know that the meters would cancel, right? And then we multiply fractions straight across, we would get 360.8 feet. So we end up with the same answer, right? But notice what we multiplied. We multiplied the 110 by the 3.28, and that's what we get when we do our cross products as well. And when we set up the cross products, right, we're setting them equal. Okay, we're setting them equal to one another. And that's why we have to be consistent, right? If I have feet on top of the ratio and meters on bottom, I have to have that in both of my fractions so that when I actually do multiply, right, the meters cancel out and I'm finding just the feet. All right, so that's the second part. We actually solved it. So here's the setup part one, solve it. We got 360.8 feet in part two. All right, your practice is on page 273. You can see the numbers to work on there. Do that on a separate sheet of paper and use the answer key to solve. Hope everyone has a great day, and we'll talk to you soon.